Hello and welcome back to Get Great at Maths. I'm here to help you pass your maths exam, so hit that like and subscribe button. We're going to look at keywords, key formulas and how to gain top marks. So let's get ready to get great at maths. This is a question on graphical inequality and area. The keywords in the question are we've got the graph of y equals 2x plus 1 and you're told that this graph is drawn on the grid. So you can see the line here of 2x plus 1 is drawn for us. And we've got to work out the region R which satisfies the inequalities. And these are the three inequalities. Y is less than or equal to 2x plus 1. Y is greater or equal to 5. And x plus y is smaller or equal to 13. And we've got to show that the region or the area of the region R is 12 centimetres squared. And this is going to be worth 6 marks. Now, all inequality questions are worth lots of marks, so they are something that's worth knowing how to do and make sure you know how to do them well. Now, your key facts for this question are that first of all, you've got to draw these lines. So the first one has already been drawn for us, y equals 2x plus 1. But you've got to draw these other two lines on here. And you've got to treat these signs as equal. So in between here, you think of this as an equal. So y equals 2x plus 1, that is what has been drawn. So you're going to draw y equals 5 and x plus y equals 13. So you're going to treat them as equal signs. Remember, if you've got y equals to a value, that gives you a horizontal line. So here's your y-axis. So whatever value y equals, it is going to draw a horizontal line coming across for y equals. If it was x equals, it would be a vertical line. But here we've got y equals, so it's going to be horizontal. Now, if you don't know how to draw the table, if you don't know how to draw the line, then you can use a table of values to plot. So take the x values to always be 0, 1 and 2. These are the three easiest values that you can use. And if you substitute these values into this equation, then you can work out the y values. And then once you've got the y values, you can plot the coordinates to draw the graph. Or you could work out the gradient and the y-intercept. So for example, on this equation here, I've got y equals 2x plus 1. The plus 1 is where I cross the y-axis. So this is my y-axis. You can see I cross at the point 1. The number in front of the x is called the gradient, and this is 2 in this case. That means for every 1 I go across, I go up 2 squares. So every 1 square across, I go up 2. 1 square across, I go up 2. That is what the gradient of 2 means. So the gradient is the difference in y's divided by the difference in x. So 2 divided by 1 is 2. So the gradient of this line is 2. It is how steep it is. It's too steep. And then it crossed the y-axis at this point here, 1. So if you prefer to think of it as using the gradient and the y-intercept, you can do that on this equation here. Or you could put the values into the table of values. Either way will help you draw this line here. Now you've got to decide whether you're going to be drawing a whole or solid line, like you can see here, or whether it will be dotted. Now if it's just greater than or less than, it's going to be a dotted line. But if it's greater than or equal to or less than or equal to, you draw a solid line. So in this case here, these have all got the equal to signs in, so they're all going to be solid lines like the one you can see here. You've then got to identify the region. Now to identify the region, if you put in a coordinate, and the easiest coordinate is to put in is the point 0, 0, but you're going to put that into the inequality and you're going to see if it is true. If it is true, that's the region you want, so then you shade the opposite side because that's the region you don't want. So you always shade the region not required, so you're left with R in the middle. Now shading and identifying the region is quite tricky. If your line goes through the point 0, 0, you can choose any coordinate. So if this line here had started and going through the point 0, 0, 0, 0 is not very helpful for me. So you could have just picked the coordinate 2, 1 or whichever coordinate you find useful to help you solve whether your inequality is true or not. But this is the easiest coordinate to use. Then you also need to know the formula for the area of a triangle, which is going to be half the base times the height. And that is the region R has got to be 12. So you've got to use this formula here to show that this region is 12. Now normally when you've got 3 lines drawn, a 3-sided shape is a triangle, so it is likely that you're going to be working out the area of a triangle. So that will give you a bit of a hint when you're drawing your lines as to which is the required region, because you're looking for a triangle. You're drawing 3 lines, it's got to be a triangle, because you've got 3 sides to the triangle. Press pause, have a go at working out the answer, and then press play when you're ready to hear the answer. Well done, guys. Hopefully you've had a good think and been able to draw this out and work out what these 3 lines are doing. Identified the region Y at R, and then showing that R is 12 centimetres squared. So to start with, we're going to look at this top equation here, y equals 2x plus 1. Now we're going to look at putting in the coordinate 0, 0. So this is my coordinate here, the origin, 0, 0. Now y is equal to 0, so I put y as 0. X is equal to 0, so 2 times 0 is 0. So I've got 0 is less than or equal to 0 plus 1. Is 0 less than 1? Of course it is. This is true. So this means this point here underneath the line is true. So I want the area underneath this line, which means I'm going to shade the area above the line. So that will give you 1 mark for shading above the line here for identifying the correct region. The next bit we're going to look at is this line y is equal to 5. Now the line y equal to 5 is a horizontal line and it crosses the y-axis at 5. So you can see here I wrote y is equal to some value, draws a horizontal line. So this one's really easy to draw, y is equal to 5. You get 1 more mark for drawing the line y is equal to 5, that is worth 1 mark. From here, you then need to look at, do we want above or below the line? So we want to know when y is greater or equal to 5. So greater than 5 has got to be above the line. So we don't need to substitute in the coordinate because when it's just equal to horizontal or vertical line, it just makes sense. So I want to know when y is bigger than 5. So here's my line y equals 5. So bigger than 5 is the area above. So I shade the region below because this is what I don't want. Okay, so I want this region above in here. So far, this little corner bit here is looking good for what I'm looking for my area. But I've got 1 mark here for the second shaded area, 1 mark for my first, and then the third for drawing this line. The next line we've got to draw is the trickiest. X plus y is equal to 13. Now you can do it by rearranging this equation and looking at the gradient and the y-intercept. We're going to do it by using the table of values first, and then I'll talk through the gradient and intercept so you can choose which one you prefer. Now, if our x is equal to 0, 0 plus something has got to be equal to 13. So 0 plus 13 equals 13. So the missing value here is just 13. So if x is 0, y is 13. We could do the same for 1 and 2. So if x is equal to 1, 1 plus something is equal to 13. 1 plus 12 equals 13. So the missing value was 12. And we do the same for 2. So 2 plus something is equal to 13. Take 2 from both sides. 13 take away 2 gives me 11, or 11 plus 2 gives me 13. So these are my points I'm going to be plotting. So we need to plot the point 0, 13. So that means you go along the corridor 0 and then you go up to 13. So there's your first point you're plotting. The next one we go along the corridor once and then we go up the stairs 12. So we go across 1 and then up 12. This is the second point. And then we go across 2 and up 11 for the third point. So across 2, up 11 gives me 3 points. You only need 2 points to identify a straight line, but 3 will check that your straight line is correct and all these points are in a line, then you have done it correctly. Once you've got these 3 coordinates plotted, just draw a straight line to continue from one axis to the other. You will spot that if you've got an equation where it's x plus y equals to any value, it will always go through the number 13 on both axes. So whatever number is here, it will be exactly the same, and it is a line that goes diagonally between these 2 points here. Now if we rearrange this equation to give me y is equal to 13, take x from both sides, gives me y is equal to 13, take away x. You can see that the y-intercept is 13, so crosses up here. And my gradient, when I take this over to the other side, the x becomes minus 1. So that means for every one I go across, I've got a gradient of minus 1, so I go down 1 this time. So my gradient is negative 1. So it's got a line slope in the opposite direction because it's got a negative gradient. Doesn't matter which way you plot the graph, as long as you can get this graph drawn, that will give you your 4th mark. Next, we need to identify which region. So we're going to take this equation here and we're going to substitute in the point 0, 0. So x is 0, y is 0, looking at this coordinate here. 0 plus 0 is less than 13. Is that true? Of course it is. 0 is less than 13, which means the point here is true. I want this point here, so the area under this line here is the area I want. So the area I don't want is the area above, so this is your 5th mark for identifying this mark here, this area here, which means my region is this area here, this section here in the middle, the triangle. As we expected, we were looking for a triangle because you've been given 3 lines, 3 sides, which means you've got a triangle. Now we've got to use this formula for the last mark to work out the area of the triangle. So the area of a triangle is a half the base times by the height. So we need to identify the base, which is this distance across here. So that is 1, 2, 3, 4, 5, 6 squares. So we've got 6 squares across. And then vertically going up is the vertical height. So at perpendicular height, which is this distance here, which is 1, 2, 3, 4 squares up. The formula for the area of a triangle is a half the base times the height. So a half of 6 times by 4. You are allowed a calculator for this question, but a half of 6 is 3 times by 4 will give you the 12 centimetres squared, which is shown for 1 mark. So this is where the last mark comes from. Remember, mark your answer, give yourself a tick for where the marks were awarded so you can clearly see where you get the full 6 marks for this question. Inequalities always come up on one of the exam papers. Make sure you know how to do your graphical inequalities and you understand how to work out the regions. The mark scheme on this question shows there are 6 marks. B1 is a method mark. M1 dependent, or dep means dependent, it means it depends on where you shaded your region. So you can see here on the left hand side, this is the correct diagram. But if you identified the wrong triangle, say you identified this triangle over here on the left-hand side, and you worked out the area of this triangle, you would get a method mark for doing it for the area of your triangle. OE means or equivalent. The word condone means allow. So if you don't have a ruler in the exam, which I don't recommend, make sure that you bring your ruler to the exam, but they say a good freehand line, which can be dashed or solid. So if you made a mistake, you can still get a method mark that is still allowed. So make sure you've read the guidance which is allowed and not allowed on the exam. If you found this video useful, please share, like and subscribe so we can all get great at maths. If you've enjoyed this video, please don't forget to share, like and subscribe. Please follow Get Great at Maths on TikTok, Instagram, Facebook and X. What do you want to see next on Get Great at Maths? Please comment below. See you next time.